Hello and welcome to my presentation. Today I'll be talking about sensing and estimation. Have you ever seen a robot without any kind of sensor? Probably not. This is because sensing and estimation play a major role in any kind of robotic system. I'm a second-year mechanical engineering student that has been studying this topic for the last semester, and today, by watching this presentation, you'll be able to learn more about the most popular sensing and estimation techniques that are widely used all across robotics. My presentation will be divided into four major parts. First, an overview about sensors, then processing and making predictions with the data we've obtained. Thirdly, we'll be talking about what makes a robust estimation method, and to finalize, we'll be talking about different ways to represent the data we've obtained. Before we can even start this, we need to get the data. This is where sensors come in. Sensors allow us to gather their data from the environment or the robot itself, so that makes them very useful. They can measure a wide variety of things. For example, they can measure from length to angular momentum to even gather images from the exterior. Sensors are divided into two major categories. First, there are active sensors. Active sensors emit a signal into the environment and measure the response. The most commonly known example of this would be radar. While, on the other hand, we have passive sensors. Passive sensors just recompile the data that is already present in the environment, like for example cameras. Now that we have obtained this data, we need to process it in order to make estimations. But why would we want to make estimations? Well, estimations will be useful because we want to know how the system is and will be in order to make decisions in advance. For linear models, the most commonly known and used method is the Kalman filter. The Kalman filter is a very complex process, but basically what it does is it makes prediction of future measurements based on the current state, while also taking into consideration the corrupt or incorrect data and noise that can be present because of the sensors. Because of this, we say that the Kalman filter is a very robust method. But what exactly makes a robust method? Well, to answer that question, first we need to define what a data outlier is. A data outlier is a very corrupt or abnormal piece of data that can mess up our measurements. We have two factors to measure how well a system can tolerate this. First is the breaking point. The breaking points measure how many data outliers can the system receive before giving wrong predictions. While on the other hand, we have the influence function, which measures how much a single data outlier can affect the final measurement. Another way to increase robustness is by implementing what is called a voting-based system, like in society with democracy, basically consists in two or more parallel systems that measure the same thing, and we gather the information, the measurement based on the vote of the majority. And also, another very popular method of reducing noise by the sensors, it is called k-means clustering. This is also a very complex method, but basically what it does is it grabs a cloud of data and compiles it and reunites it in a single point based on the median in the center. This allows us to decrease the noise. Another way we have to improve the accuracy of sensors is by modeling. We can either model them on virtual representations in computers or by making prototypes in real life. This allows us to measure basic distortion and the different ranges of measurement that a sensor can have, allowing us to know if the sensor is suitable for this job. Now that we have gathered and processed and made predictions on the data and the surroundings, we would like to make representations in order for them to be useful. There are many types of representation, but the most popular are feature-based representation, in which basically we just extract the most important characteristic of any measurements while ignoring the rest. And on the other hand, the second most popular is graph-based representations. This allows for a very easy way to representing the data we have gathered. With this, we have finally finalized the perception and estimation process. And with this, we can see that the major 4 parts in this are the sensors, the processing and the estimation of future data, allowing and having a very robust estimation system, and representing the data. Thanks for your attention.